The darkness between galaxies seems motionless, silent, empty. But far beyond the usual star clusters, something so huge is hidden that even light is lost among its size. In the cold ocean of space, a giant slowly floats whose boundaries are almost impossible to determine. Its radiance is stretched for millions of light years, and the very structure of space curves around it. This IC 1101 is one of the largest known galaxies in the universe. Its light began its journey through space even when many modern star systems were just forming. Today, this ancient stream of photons reaches the observable universe after billions of years of wandering through intergalactic darkness. IC 1101 is located at the center of the huge galaxy cluster Abell 2029 in the depths of the constellation Serpens. But even among giants, it looks like something anomalous. Most galaxies have distinct shapes, spirals, ellipses, elongated structures. IC 1101 seems to go beyond the usual cosmic scale. Its size is so colossal that the outer regions dissolve into the surrounding space, as if the galaxy itself is gradually mixing with the darkness of the universe. The diameter of IC 1101 is estimated to be millions of light years. For the cosmos, this is an almost unimaginable value. Inside it are trillions of stars. Their number is so great that even the faint glow of distant regions turns the galaxy into a gigantic glowing ocean.
But the most mysterious thing is not hidden in the stars. At the very center of this structure is a supermassive black hole of monstrous size. Its mass can reach tens of billions of solar masses. The space around her is distorted to the limit. Matter that comes too close disappears forever, dissolving beyond the event horizon. There is almost no calm around IC 1101. Intergalactic space is filled with hot gas that glows in the X-ray range. Huge streams of matter slowly move towards the center of the cluster. The gravity of a giant galaxy holds countless star systems and clouds of plasma around it. Within this cosmic monster, collisions, takeovers, and destruction are constantly taking place. Small galaxies that get too close gradually lose shape. Their stars are torn out by gravity and become part of the giant structure of IC 1101. This galaxy has been growing for an incredibly long time. For billions of years, it consumed neighboring systems. Each merger left traces, new streams of stars, giant halos of light, chaotic gas movements. Over time, the boundaries between the absorbed galaxies disappeared. Everything was mixed into a single colossal mass. That's why the IC 1101 looks so unusual. It's not just one galaxy. This is the result of countless ancient collisions that took place during the vast epochs of the universe's existence. The light inside the IC 1101 is uneven. The central areas shine especially brightly. The density of stars there is colossal. Gravity holds the giant clumps of matter at bay, and the temperature of the gas reaches millions of degrees. But the farther away from the center, the stranger the structure of the galaxy becomes.
The outer areas are extremely sparse. Individual stars are separated by enormous distances. The light becomes weaker and seems to dissolve in cosmic darkness. It is because of this that it is incredibly difficult to determine the true dimensions of IC 1101. Some estimates make it one of the largest known galaxies ever. Inside such giants, time seems to flow differently. Stellar orbits can take millions of years. Gravitational waves pass through vast regions of space. Streams of dark matter surround the galaxy in an invisible framework. Without this hidden mass, IC 1101 would not have been able to hold its structure. An invisible gravitational field binds together trillions of stars and giant clouds of hot gas. The central black hole remains especially mysterious. Its influence extends far beyond the galaxy's core. When matter falls inward, a red-hot disk forms around the event horizon. The temperature in these regions is so high that matter begins to emit powerful radiation. Sometimes giant jets of plasma burst out of the center, moving almost at the speed of light. These streams are capable of stretching for hundreds of thousands of light years, cutting through intergalactic space. IC 1101 is located in one of the densest regions of space. The Abell 2029 cluster contains a huge number of galaxies bound by common gravity. Streams of hot gas and dark matter move between them. But even in the midst of all this gigantic surroundings, IC 1101 dominates. Its mass is so great that the motion of many nearby galaxies depends on its gravitational influence.
Sometimes, powerful supernova explosions occur in the outer regions of the galaxy. Giant stars end their existence with catastrophic flares, throwing heavy elements into space. These explosions illuminate parts of the galaxy brighter than millions of stars at once. They leave behind neutron stars, black holes, and red-hot nebulae that slowly expand along the interstellar medium. But even such processes are almost imperceptible against the background of the true scale of IC 1101. This galaxy is too huge. It takes millions of years for light to cross it completely. While the radiation leaves one region, new collisions of galaxies, the birth of stars, and the destruction of entire star systems are already taking place in another.
Inside the Abell 2029 cluster, space is filled with a faint glow. This is the light of stars torn from other galaxies. They no longer belong to any systems and move freely in the intergalactic darkness. Many of them were captured by the gravity of IC 1101 during ancient mergers. The giant galaxy seemed to gradually collect more and more matter around itself, turning into a real center of gravity of a huge region of space. Some regions of IC 1101 contain almost no young stars. The bulk of the luminaries there are very ancient. Their light is redder and weaker. This means that the turbulent eras of star formation are long over. But individual galaxy collisions can still trigger new waves of starbirth. When giant clouds of gas collide, gravitational compression begins. New incandescent stars appear, illuminating the surrounding space with a bluish glow.
Even the IC 1101 form itself remains a matter of mystery. Some areas look almost perfectly elliptical, but the outer parts are too blurry and huge. Perhaps its structure continues to change right now. The gravity of neighboring galaxies, dark matter, and constant mergers are gradually changing the shape of this giant. Huge masses of hot gas move around the center of the cluster. Their temperature reaches tens of millions of degrees. Such a substance emits powerful X-rays. It is because of this that the Abell 2029 cluster looks like a giant luminous node in the depths of space.
Inside it, IC 1101 occupies a central position, like the core of a huge cosmic structure.
Sometimes it seems that such galaxies contradict the usual understanding of the size of the universe. They are too big, too massive, too ancient. Their existence shows how chaotic and grandiose the cosmos can be. There is no immobility here. Even the most gigantic structures continue to change. Galaxies collide, black holes are growing, the stars disappear. Space is gradually rebuilt under the influence of gravity. Over billions of years, IC 1101 has become a veritable graveyard of swallowed galaxies. Its structure hides the remains of ancient collisions. Streams of stars, strange orbits, and torn clouds of gas are reminiscent of events that took place in the distant past of the universe. And all this continues to move in the infinite darkness of space.
Inside IC 1101, the slow, almost imperceptible movement of epochs continues. The gravitational fields are so deeply intertwined that the boundaries between the past and the present in individual regions become blurred in a physical sense. Stellar streams stretched for hundreds of thousands of light years continue to drift in orbits determined by collisions that occurred long before the structure itself reached its present size. The central region of the galaxy remains the densest and most energetically active region. Here, matter exists in a state of constant stress. Clouds of hot gas do not have time to cool down because endless gravitational compression and turbulence keep the temperature at a level at which atoms lose electrons and turn into plasma.
This plasma fills the space between stars, forming a medium in which light travels through a complex network of scattering and absorption. Inside such a core, even a void is not a void. It is an active physical medium that constantly responds to gravitational and magnetic fields. The supermassive black hole at the center of IC 1101 continues to be a key element of the entire system. Its gravitational influence shapes the dynamics of the central regions, setting the direction of motion of stars and gas at great distances. Matter approaching it accelerates to relativistic speeds and then begins to collapse under the influence of tidal forces. Inside the accretion disk, processes occur in which energy is released not gradually, but in leaps and bounds, creating bursts of radiation that can temporarily exceed the brightness of entire galactic regions.
The accretion disk around the central object is not a stable, flat structure. It is constantly changing, breaking, reforming, and condensing. In its different layers, matter moves at different speeds, creating internal friction, which converts gravitational energy into light and radiation. In some areas, magnetic loops arise that are able to push parts of the plasma outward,
forming narrow and powerful jets that extend far beyond the core. These relativistic jets pierce the surrounding gas, creating channels of reduced density in it. Moving at almost the speed of light, they transport energy over distances comparable to the size of small galaxies. When such jets interact with the intergalactic environment of the cluster, they heat it, creating huge regions of X-ray glow. Thus, the central object of IC 1101 not only absorbs matter, but also redistributes energy on scales spanning the entire Abell 2029 cluster.
In the outer regions of the galaxy, the structure becomes more sparse, but no less complex. Stellar halos are stretched so far away that individual stars can be hundreds of times larger than entire spiral galaxies. These areas are formed mainly due to ancient mergers. Each absorption of another galaxy leaves behind long plumes of stars and gas that did not immediately mix with the bulk of IC 1101, but retain individual dynamical features over billions of years. Some of these plumes form loops and arcs that span large parts of the galaxy. Their orbits are so stretched out that one revolution around the center can take a time comparable to the age of entire stellar generations. These structures serve as a kind of chronicle of past collisions, capturing the direction and strength of each event that the galaxy has passed through during its growth.
The dark matter surrounding IC 1101 forms an invisible framework that keeps the entire system from falling apart. Without this component, the stars in the outer regions would have left the galaxy long ago, and its structure would have begun to gradually collapse. However, the gravitational influence of dark matter creates a stable potential within which visible matter continues to move in complex orbits. The distribution of this invisible mass is uneven, and this is what leads to additional distortions in the motion of stellar streams. Occasionally, local bursts of star formation occur in the distant regions of IC 1101. They occur where residual clouds of gas collide with each other after long periods of relative rest. These collisions cause matter to contract and trigger the birth of new stars. Young stars in such regions are characterized by high temperatures and intense radiation, which creates bright bluish structures that contrast sharply with the older reddish background of the galaxy.
However, such processes cannot change the overall evolution of IC 1101. The scale of the system is so large that local events are lost in global dynamics. The galaxy continues to exist as a single gravitational organism, where each motion is associated with millions of other motions, and each structure is part of a larger process of redistribution of mass and energy. Inside the Abell 2029 cluster, the space between galaxies is filled with hot gas that slowly circulates under the influence of common gravity. This gas is not static. It is constantly moving, heating and cooling, creating a complex thermodynamic system. IC 1101 is at the center of this flow, affecting its structure and directing the movement of matter in the surrounding space.
As you move away from the center of the cluster, the density of matter decreases, but the influence of gravity remains noticeable at great distances. Even the most distant galaxies inside Abell 2029 are connected to the central region through weak but constant gravitational interactions. These connections form a slow, almost imperceptible circulation of matter within the entire cluster. Over time, IC 1101 continues to accumulate mass. New galaxies approaching its gravitational field gradually lose stability and begin to collapse. Their stars stretch into long streams that eventually become part of the outer halo. This process is so slow that individual stages cannot be observed directly,
but traces of it are visible in the overall structure of the galaxy. The energy flowing through IC 1101 is unevenly distributed. The central regions dominate the radiation, while the outer parts remain dimly luminous. However, it is the outer regions that contain the greatest mass of stars. This creates a complex energy asymmetry, in which light and mass are distributed differently, forming a unique structure that is different from most other galaxies in the universe. Over time, the dynamics of the IC 1101 can lead to an even greater increase in its size. If the process of merging with neighboring galaxies in the cluster continues, its gravitational potential will increase, increasing its influence on the entire surrounding space. In this case, the structure may become even more extended, and its outer boundaries may become even more blurred.
But even without new collisions, the galaxy remains a stable system, existing on timescales inaccessible to direct perception. Its stars continue to rotate, gas circulates, dark matter holds the structure, and the central black hole gradually changes the surrounding space. And in this slow cosmic dynamics, IC 1101 remains one of the largest and most stable formations in the entire observable universe, where each movement is part of a process stretched over billions of years and spanning distances that cannot be expressed on the usual scales.
Beyond the bright central glow of IC 1101, a region begins where the galaxy gradually transitions into intergalactic space. Here, it is already difficult to determine where the structure itself ends and the surrounding darkness of the cluster begins. The light becomes so diffused that individual streams of stars appear as a faint silvery glow dissolved in the void. But even these almost invisible regions remain bound by the general gravity of the giant system. The outer halo of IC 1101 is not only made up of ancient stars, it contains huge masses of dark matter, invisible clouds of rarefied gas, and the remnants of destroyed galaxies that have been consumed over billions of years. Some of these structures continue to move in old orbits, retaining the memory of ancient collisions. Gravity slowly stretches them more and more, turning them into long streams of matter that can stretch for hundreds of thousands of light years. Within such streams, there are sometimes globular clusters, dense groups of ancient stars that survived the destruction of their original galaxies. They continue to move around the center of IC 1101 like relics of the distant past. Many of them contain some of the oldest stars in the entire system. Their light is faint and reddish, and the temperature is much lower than that of young, hot stars. These ancient stars slowly use up the remnants of their fuel, existing in an almost unchanged state for vast epochs. Deep inside the central regions, the situation is quite different. There, the space is saturated with energy. Huge magnetic fields cross the accretion disk of the supermassive black hole, creating complex plasma vortices.
The particles accelerate to extreme speeds and collide with each other, giving rise to powerful radiation. Sometimes these processes become so intense that the central core of the galaxy begins to glow brighter than the surrounding regions of the cluster. Huge masses of matter are constantly moving around the nucleus. Some clouds of gas gradually lose speed and fall closer to the center. Others are ejected by flows of energy that occur near the event horizon. This creates a continuous cycle of matter motion. Some of the matter disappears inside the black hole, and some returns back to the interstellar medium in the form of red-hot plasma and shock waves. When such shock waves pass through gas clouds, they are able to trigger new star-forming processes. In some areas, dense clusters of young blue stars appear. Their radiation is so intense that the surrounding gas begins to glow with bright shades of the ultraviolet and X-ray range. However, these young structures live relatively short-lived. The most massive stars quickly run out of fuel and end their existence with colossal explosions. Supernovae inside IC 1101 occur regularly. Each such flash throws heavy elements into the surrounding space: iron, nickel, oxygen, silicon. These substances mix with the interstellar medium and become part of new generations of stars and planetary structures. In this way, the galaxy gradually changes the chemical composition of its own space. Over billions of years, the content of heavy elements inside it has increased significantly. But even supernova explosions are lost against the background of other processes occurring in the system. In some areas, giant clouds of hot gas collide, creating turbulence on a colossal scale. Magnetic fields twist and tear, releasing huge amounts of energy. Cosmic ray particles permeate the space of the galaxy, moving at almost the speed of light through millions of light years.
The Abell 2029 cluster around IC 1101 remains one of the most massive gravitational nodes in the observable universe. Its central regions are filled with hot plasma, the temperature of which reaches tens of millions of degrees. This environment is so hot that ordinary atomic structures cannot exist in a stable state. The electrons are separated from the nuclei, forming an ocean of ionized matter that glows in the X-ray range. The galaxies of the cluster move through this space. Their speeds reach thousands of kilometers per second. Some pass relatively close to IC 1101, falling under the influence of its monstrous gravity.
At such moments, the gradual destruction of their structure begins. Outer stars burst out by gravitational tides, gas clouds lose stability, and the galaxy itself begins to stretch and deform. Sometimes, such collisions lead to complete absorption. Then, IC 1101 becomes even larger. The stars of the collapsed system are scattered inside the giant halo, and its central black hole may eventually merge with the central object of the giant itself. Such events are accompanied by powerful gravitational disturbances propagating through space in the form of gravitational waves.
These waves travel through the fabric of space-time, carrying information about the collisions of objects of colossal mass. Inside IC 1101, similar processes may have occurred many times in the history of the galaxy. Each merger of supermassive black holes changed the structure of the central region, ejected stars into new orbits, and redistributed energy within the system. Some models suggest that IC 1101 may have been even more active in the past. The central core may have emitted significantly more powerful relativistic jets that penetrated far beyond the galaxy and affected the entire Abell 2021 cluster. Traces of these ancient emissions may persist in the distribution of hot gas and magnetic fields around the system.
Even now, the cosmos around IC 1101 is not calm. Plasma flows continue to circulate between galaxies. Magnetic fields permeate intergalactic space. High-energy particles collide with gas clouds, creating faint gamma radiation. All this forms a huge dynamical system, within which IC 1101 remains the main center of gravity. The deeper such giants are studied, the more obvious the scale of cosmic evolution becomes. Ordinary spiral galaxies appear to be small structures against the background of such supergiants. IC 1101 shows that the universe is capable of creating objects whose size is far beyond the usual understanding of galactic scales.
And somewhere in the depths of this gigantic stellar ocean, the endless movement of matter continues. Ancient stars are slowly fading. New luminaries flare up among the clouds of gas. The black hole in the center continues to absorb matter. Gravity binds trillions of objects into a single structure. And all around, beyond the faint glow of the outer halo, lies the cold and almost endless darkness of intergalactic space, in which IC 1101 continues to grow slowly, remaining one of the most grandiose objects in the known universe.
But even such a galaxy will not exist forever. Billions of years later, the stars inside IC 1101 will become smaller. Huge blue stars will disappear first, leaving behind black holes and neutron remnants. The brightness of the galaxy will begin to slowly fade. Cool red stars will shine longer than others, maintaining a faint glow in near total darkness. The central supermassive black hole will continue to grow. More and more matter will disappear beyond the event horizon. Huge regions of the galaxy will gradually become calmer. Clashes will occur less frequently. The reserves of gas from which new stars are born will eventually run out. IC 1101 will evolve into a gigantic ancient structure filled with the dim light of old stars and the cold remnants of long-gone eras.
But even then, its gravity will remain colossal. Dark matter will continue to hold a giant halo. The star streams will move slowly through the intergalactic darkness. The space around it will preserve the traces of all ancient collisions, all the absorbed galaxies, and all the processes that have shaped this cosmic giant for billions of years. IC 1101 remains a reminder of the true scale of the universe, about how huge structures born in the depths of space can be. In the midst of endless darkness, it continues to float through space with its cluster of galaxies, surrounded by hot gas, invisible dark matter, and the light of trillions of stars.
And as the universe expands further and further, this gigantic ancient world continues to exist in the cold silence of space, one of the largest and most mysterious objects known among the countless galaxies of the boundless universe.